Good morning, everyone. My name is Dr. Nagaraju, working as assistant professor in the Department of CSCA and ML in Institute of Aeronautical Engineering, Hyderabad. So, welcome to the fourth session on the Prolog fundamentals. So, in this particular session, we are going to talk about a specific data structure which is called as list in terms of the Prolog programming. So, first we will try to see the different kinds of notations which are used in order to work with this list. Then after we will try to see one or two operations which we can perform on the list. Okay, so let us directly move into the concept and we will try to understand what this list is and how this list will be useful in order to organize certain kind of elements or objects. Okay, like that. Okay, so as I mentioned that it is a one kind of data structure. So if you take in Python, there are different kinds of data structures are available for us, like dictionaries, tuples, like that. In a similar fashion, when it comes to the Prolog programming, we are having the most important and most common data structure which is called as list. So that's why it is very important. For example, why? Because for writing any kind of AI related problems, problem solving programs, then definitely we are going to make use of this list. So you should supposed to understand what this list is, how this list representation can be performed. So why I am doing this kind of stress on this particular point means the way how we represent and the way how we use the data structures in the other programming languages, it will not be same in this case. So Prolog is going to have different way of representing the list, where we are going to organize different kinds of elements or different kinds of items, or we can say different kinds of objects. So let us directly move into the concept, that is we can say that is in simple words. Means if you want to talk in simple words, we can say that a list is nothing but a simple data structure and which is widely used for non-numeric programming. Which is used for non-numeric programming. So this kind of thing is not there in the other programming languages. Means especially if you see the Python, what happened? We are going to represent some kind of numbers in this particular fashion, and we will call it as some kind of a data structure. Okay, representing certain kind of elements. But here our concentration is not only on doing these kind of representations, but also we are having more concept in doing it. Means not only just having some kind of numerical values and organizing into a particular data structure, and we are not going to say that it is a list. Okay, so we will try to see each and everything, but for simple understanding you can take this particular definition here. What is that? A list is a simple data structure which is widely used in non-numeric programming. Or otherwise we can say that in simple words, it is a sequence of any number of items. Okay, it is a sequence of any number of items. So in this case, as I have used the word called as non-numeric programming, so I want to take the examples of the strings like that. So in this particular case, I am calling these strings as items. So if I say that a list is a sequence of any number of items, so what are the items I am taking here? One is Ram, another one is Rahim, and another one is robot. So by using by using these three items, we are going to frame up a list, and we are calling that a list is a sequence of such kind of numbers or such kind of items. So in simple words, we can say, means the list can be represented in a particular fashion. So the first common way of representing the list items is using the square brackets. So in the square brackets, we need to represent what are the items we are considering. So one is Ram, another one is Rahim, and the third one is robot. Okay, so it can be any kind of word. So what we have done, a sequence of items we have taken, and those sequence of items we need to separate with comma. We need to separate it with comma, and we need to enclose all these things in the square brackets. Okay, so this is not only the one way of representing the list, but I am saying that this is the most common way of representing the list items. So the representation is only the external appearance of list. So whatever the representation we are doing, it is only for the external representation. Means we can say that for the user's perspective, means only for the user requirement, we are representing the list in this particular fashion. But when it comes to the Prolog, right, the representation of list will be in the form of a tree. It will be in the form of a tree. Okay, so how it will be means it is going to be like this. Some list item, we can say I1 we can consider, later on it can be I2. Okay, so it can be I3. Okay, so this kind of representation will be done. Means internally, whenever you whenever you represent a particular list, that list is going to be represented in the form of a tree. Okay, so we can consider that the way of representing this particular thing is for the user's perspective, means for the user's need, and internally how the Prolog is going to organize those things, means it is in the form of trees. We will try to understand these things by taking one simple example. So I said, see here, there are two different cases where the list is either empty or non-empty. So in the second slide, we told that we mentioned that a list is a sequence of items which are enclosed within the square brackets. Okay, and each and every item is going to be separated by comma. But here what we are doing, we are saying one more important point, that is a list can be either empty. Means simply you take some square brackets and don't write any of the list item inside it. So a list is a sequence of items. Also we can say a list can be a single item also. At the same time, even the list can be empty. Means just by representing wherever you require, means based upon your problem statement, if you require any empty list, then you can represent in this particular fashion. Prolog is going to give such kind of support to us. That's why we are saying that the list of the list can be either empty or it can be non-empty. So in case of representing Ram, Rahim and Robot, right, our list comes under non-empty. Okay, so the list is written as Prolog by using the square brackets just now I mentioned. So it can be viewed as two different things. It can be viewed as two different things. So this is very, very important. We need to concentrate here. What is that? One is head and another one is a tail. Means whenever you are creating a particular list or whenever you are representing a particular list, okay, in Prolog, the list is going to organize in this particular fashion. Means every list, we can say, means in simple words we can say that every list is going to have head as well as tail. Now we need to understand which one is called as a head and which one is called as a tail. For example, just now we took Ram, Rahim, Robot. So if you are preparing such kind of list, so which one is called as a head of the list and which one is called as a tail of the list? Means either Ram as a head or Robot as a tail. So that we need to understand. So first what we have done, we have taken the definition. Means we try to understand the definition of list as some sequence of some list items. This is the first understanding what we made. So what is the second understanding? Every list elements, we can say list elements, right? Every list elements, right? They are going to organize. Means this list item elements are going to organize in the form of head and the tail. Means there will be two parts of that list, we can say. One part is considered as a head, right, and that part is going to consider as a tail. So we are going to make use of this pipe symbol, right? This pipe symbol is used in order to separate the head part and the tail part of the list. Okay, so that's why we are saying that the first item in the list is going to considered as a head of the list and the remaining part of the list is called as a tail. Okay, so in this example, for example, what is that? Ram, Rahim and Robot. So in this case, how can we consider this one as a in this particular way, head and tail? So the first one, so up to this particular comma which is there, Ram is there, so we can consider this Ram as a head part and the remaining, right, the remaining means this entire thing, and the remaining we are going to consider as a tail. So the representation is going to be like this. Okay, so this is the example. So in this case, what happened? The head of the list can be anything like an object, a tree, or a variable. The head can be either an object, or it can be a tree, or it can be a variable. So in this case, we can say that Ram, Rahim, and Robot are some kind of objects. Right? Sometimes what happens, even you can frame the list in this particular fashion, X, Y, Z, representing in the capital letters, then we can here we say that it can be a variables. Okay, so we are going to see different variations in representing the lists in Prolog. So we will try to take another example. So just now I mentioned already one way of representing the sequence of element items in Prolog is keeping them in the square brackets, means mentioning the list of items in the square brackets. So what is the other option we are having, means even you can use the parenthesis. Okay, when it is the case, first you are going to keep a period symbol followed by the open parenthesis, then the head part separated by the comma part and the tail. So only one difference you need to consider. If it is the square brackets, the first element of the list will becomes the head, and the remaining part of the list is going to become the tail. Sorry, going to become the tail. Okay, it is going to become the tail. The remaining section, right? It can remaining part means it can be only one element or it can be more than one element. How many elements are there? We least bother. Only the first element is considered as a head, and remaining all the elements. It can sometimes what happens, even this can be empty also. Sometimes it can there can be only one element. Sometimes there can be more than one element. But we least bother, right? What it is there in the other portion, that we will consider it as a tail part. The first element is going to consider as a head part. So since tail is in turn a list, see, that's why I am telling that again tail is also going to be one kind of list. So what we can say, this entire part is a list. Okay, and even if you closely look into the tail, even this tail is also going to represent some kind of list. So that's why I said either it can be an empty one, means like this. Okay, either it can be empty one, or it can have its own head and tail again. Own head and tail. For example, in square bracket, means if you represent in the square brackets, it will be like this. You see, pipe symbol B, C, D. So what happened? This will become the head. A will become the head. B, C, D will become the tail part of the list. So this can be one thing, or otherwise it can be like this also. So it can be like this also. So in this case, what happened? The second portion of the list, what is that? It is a tail. But here the tail itself has become a list. That is the point we are talking about here. It can be either empty, but in this case it is not empty. It is non-empty with its own head and tail. So in this case, means in this particular portion, the head is the B and remaining C, D will become the tail. So like this we can represent the list in the Prolog. So therefore we can say that represent the list of any length, no additional principle is required. So this is a common and most basic principle we are going to use while representing the list. So we will take this example. So what this example is telling all about. So it is by default it is a list. By default it is a list. But if you are representing a dot with only open and close parentheses, then we can say that it is just a list with one head and remaining part as a tail. But here what happened, we are using many number of parentheses, open parentheses. Okay, so in this case we can say that the other portion of the list, what is the other portion? Tail. The other portion of the list again representing one more list. For example, in this case what happened? This became the head. The remaining entire portion has become the tail. This entire part we can say it has become the tail. But again the tail itself is representing one more list. So in this case what happened? This became the head and remaining part has become the tail. So again in this tail, again we are having the head part. Okay, the remaining portion will become the tail. So like this it is happened. So what we can say, this kind of representation is representing the list inside a list. Means even Prolog is also going to support these kind of things. Only the thing how we are going to come to know that this representation is having sublists also, means by seeing this period symbol. Okay, by seeing this period symbol followed by the open parenthesis. Okay. So just now I told that these kind of representations means either you can use the square bracket representation or you can use the dot and the open parenthesis and close parenthesis representation. But this representation is only for the external usage, for our understanding, for the programmer understanding. But what happens if we declare or if we define these kind of lists internally? So just now we mentioned the point that these kind of representations are going to be represented in the tree-like structure, using a tree-like structure. So how this tree-like structure representation will looks like? So this is a diagram clearly telling all about. Okay, so what does it mean? The complete list, for this particular list, this is the head. I mean, remaining entire part will become the tail. But just now we have seen that the other part of the tail means the main list is again having a one more list. For that sub list, we can say for that sub list, here 10s has become the head and remaining portion has become the tail. Okay, like this the representation is going to be means the structure is going to represent by using some kind of tree representations. Means the representation of this kind of link is exactly matches with the graphical representation what we have done here. Okay, right, like this it will be. So as I said, Prolog is going to support. Okay, it is also going to help provide a provision that either you can use the square bracket representation or otherwise you can use this parenthesis representations also. But the most common one is using of the square bracket representations. Why? Because these kind of representations it will be little bit difficult to understand. Let's try to see some kind of possible conversions with the Prolog. So how the Prolog conversions will be done? Means taking the same list and trying to represent in different ways. So in this case, you observe the first one, taking some sequence of elements like X, Y, and Z. These are represented in small letters. That's why we can say these things as objects. By using these list of items or objects, we have created. Okay, we have created a list and naming that list as list 1. The same kind of representation even you can do with the open parenthesis also. So the exact means the equivalent representation of this one is this. Okay, either you can represent in this particular fashion, there is no problem. So list 1 equal to some XYZ, and at the same time what happens, even list 2 is also XYZ only. That's why we are saying that these two may be two different way of representing, but we are representing or we are enclosing the same kind of elements in the list. Okay, so that is up to the programmer to make use of either the square bracket representation or the open parenthesis representation. We'll try to see some kind of examples. So what is examples? One example is hobbies equal to some kind of list we have taken. So cricket followed by the tail. So this cricket is a head and remaining part is going to be the tail. But what happened, again there is a dot symbol here. Okay, there is a dot. So what this dot represents means a sub list is there. Means in the main list, the tail portion is having one more list. So what that one more list is having? Music and the empty list. So music has become the head part and remaining thing will become the empty list. Okay, means you can take the list as a empty list, or you can take it as a non-empty list, or you can take as a combination of both. Means one single list can have a empty list as well as it can have the non-empty list also. Okay, so that like that we can take the representations. There is no issue. So L equal to what happened? There is one kind of representation. What is that? One is Ram, second one is hobbies 1, next is Rahim, and the fourth one is hobbies 2. So in this case, what happened? Already we have created these two lists. Two lists with cricket and music, and the other list is trekking and food. Okay, so in this case, what happened means whenever you execute the Prolog code, these two objects, so these are the two list objects. When you execute, these two list objects are going to be replaced with the list items. Going to be replaced with the list items. So at the end, we are going to see the entire representation in this way. Rom is the most common one. Why? Because we have mentioned here, and later on hobbies. So this entire thing is going to come up here. Later on, Rahim is as usual. Why? Because Ram and Rahim belongs to this particular list, L. But cricket and music belongs to hobbies 1 and trekking and food belongs to hobbies 2. So the representation will be in this particular way, right? You need to mention a square bracket here. So we will try to work more on the bracket notation. So we mentioned that bracket representation is the most common representation, right? So we can list any number of elements followed by the pipe symbol. Pipe symbol indicates the remaining elements of the list or the remaining items of the list. So what is the alternative way of writing such kind of list? So you see X, Y, Z is a common way of representing the list in the square brackets. So this representation you can represent either in this particular way. So if you represent in this particular way, we call that X is a head part of the list and the remaining part is considered as a tail part. Okay, otherwise you can represent in this particular fashion also, X comma Y followed by the pipe symbol and the remaining thing. So like this also it can be, or otherwise you can take in this particular fashion also. So in this case what happened, the tail part of the list is Z and here that means non-empty and here it is empty. That's why we are telling that whenever there is a pipe symbol in the representation, the left side portion of the pipe symbol is going to become the head and the right side portion of the pipe symbol is going to become the tail. We will try to see some of the operations that we can perform on the list. So the first most common operations we will try to see 1 or 2 and later on in the next session we will try to cover more other operations. So first, what is the first operation we are going to learn here is checking whether some object is an element of a list which corresponding to checking for the set membership. So checking is nothing but some kind of search process we are going to perform. So what is that search process? Means we are going to determine whether a particular item is the member of that particular list or not. For example, you see we have created one particular list like ABCD. Okay, ABCD, and this is the list and we have trying to search for C. So checking whether some object is an element of list. So what does it mean? Mean checking whether this C item is the part of this particular list or not. So that thing even we can also say that it is nothing but trying to check the set membership also. Set in this case this one. Whether this C belongs to this particular set or not. Whether this C we can understand in another way, right? Whether we can whether this C is the member of this particular list or not. So that is the first operation. So what is the second operation? We are going to see concatenation. Okay, concatenation of 2 elements obtaining the third list. Sorry, concatenating 2 lists and obtaining the third list. So we can say that these are the operations even we can see in the other programming languages also. Right, performing the search process to see whether a particular item belongs to that particular data structure or not. And the second one is performing the concatenation. So as usual, we see some kind of concatenation of 2 different strings and creating one more string, new string. Okay, so adding of a new operator we are not going to cover now, but we will try to concentrate on these 2 things now. So the second operation we are going to see is here concatenation of 2 lists which are going to obtain, means the concatenation process is going to generate a new list for us, which is the third list with a combination of the items that present in the both lists. So even such kind of concatenations, even we can call it as a union of sets. Okay, you don't get confused here. The word set itself is telling about the list. Try to see the first operation, which is called as a membership operation. So the implementation of membership operation is going to be like this: member of X comma L. You try to observe. Don't get confused. Why? Because the X we are going to make use sometimes in small letters and sometimes in capital letters. So what is the difference that X is? If it is a capital letter, that means that it is a variable. It is a variable. So if I am representing it as a small letters, that means that I am pointing out to a specific object. So here what happens, if you want to see or if you want to check for the membership of a particular element or particular object, then it should be like this: member of X comma L. So what this L represents the entire list. So for what we are searching for, means for what element or for what object you are looking for the membership, means it will be X. So the goal membership X comma L is going to represent in this way, and it is going to be true. So when means when you execute this one, when you are going to get the result true. Why? Because there will be two possibilities. One, you can get either true or you can get false. So in this case, we are going to see, means we are going to explain that if this is the case and if you get the answer as true, so what does it mean? Means X is the member of the list L. Or otherwise we can say X is an object which proved as a member of the set L. Okay, so like this it will be. And try to see some of the examples. So what is that examples? B comma, in the square brackets we mentioned this. So you try to observe the next parameter. So the next argument of this member function should be the list itself. It should be the list, or it can be a single list, or it can be the list with other sublists also. There is no issue in that case. So the first element is for what you are searching for what element or for what object you are looking, you are checking for the membership. So that should be the first parameter, and the second parameter is the list itself. So when you represent in this way, B comma in the square brackets ABC, then the answer is going to be true. Why? Because B is the member of this particular list. In the similar way, you try to observe B in the square brackets A comma, again B comma C. So it is a sublist. So it is not going to be true. It is going to be not true. Why it is going to be not true? Why? Because you have mentioned this B, but if this for this output you can expect it true when this A is represented with B. Then only we are going to get the result as true. Okay, so it will be like this. And the third one is member of B comma C, and in the square brackets A comma B comma C. So what happens here? Here you are not checking for the membership of only one object, but you are trying to check the membership for more than one object. So in this case, what happened? This entire portion is going to compare with the entire portion of this list. The second portion. Try to understand. If it is A here, the answer is going to be true. Right? If it is B here, also the answer is going to be true. Right? In a similar way, if there is B comma C, also the answer will be true. But if you mention A comma B, the answer is not going to be true here. Okay, so like this you need to understand. So we will try to observe one more relationship. That is, X is a member of L if either. What is that? X is a head of L or X is a member of the tail of L. So this because of these observations only we are explaining which statement is going to give what kind of result, either why it is true, why it is going to be true, and why it is going to be false. Okay, just like trying to understand the what we can say procedural meaning of the Prolog statement. So X is a member of L if either X is a head of L or X is a member of the tail of the head. Okay, you should not get confused here. So the same way we can represent, means this kind of explanation we can represent in this particular fashion. What is that? Member X comma, in the square brackets we are representing it as X pipe symbol and a tail. So as usual we can say that the output for this one is true. But in what way we have represented, means according to Prolog, this kind of representation is just a fact. It is just a fact. So we are just telling that X is a member of this particular list, and that too this X is the head of this list. Okay, according to this statement. But when it comes to here, you try to observe this is not a fact, but it is a predicate. Okay, this one is a predicate. Predicate, or otherwise we can say this one is a rule. So what is that rule? Means if you want to prove If you want to prove this particular thing, then before that you need to prove this one. Means if you could able to prove that X is the head of the list, then automatically we can prove that X is the member of this list. Okay, so like that we need to understand. We will try to see the second operation. What is that? Concatenation of the list. So as I said, list can be concatenated. Means there should be minimum of 2 lists to get concatenated to perform the concatenation operation. So CONC of L1, L2, L3. So what is L1 and L2 are? These two are the lists. So whenever you perform the concatenation of L1 and L2, you are going to get a new list which is called as L3 here. So we can say that L3 is the new list which we are going to get after performing the L1, L2 concatenation. Okay, so you try to observe here. This list means this list is going to represent L1 here, and this list is going to represent L2. When you perform the concatenation, L3 is going to come. But you try to observe why the result is true. Try to understand the procedural meaning of this sentence. What is that? A comma B are the elements of the first list. C comma D are the second elements of the second list. So the sequence how we have written A, B, C, D. Means these got after from the list 1 and these two got from the list 2. So that's why it became true. But if you take in this particular fashion, what is that? This is representing L1, A comma B is representing list 1 and C comma D representing L2. But you have, after performing the concatenation, you represented this one. We can say, sir, A, B, A, C, D both are the elements. These elements are, these items are already available in this list. So why can't this concatenated list will be true? Means it is not going to be true. Why? Because 2 elements of L1 and 2 elements of L2. So how many number of elements it should be in L3? 4 elements. That is first thing. And the second thing is, the sequence should be same. A comma B should be the first elements of the L3, and later on C comma D should be the next elements of L3. But what happened here? We have represented an extra A here. So whenever you perform the questioning of this kind of representations, the answer you are going to get is false. There should not be any additional element in L3. And the sequence of the elements from where you are getting is also must be same. Okay, so how can we define the concatenation here? So if the first argument is empty list, then the second and the third arguments must be same. This is one observation we need to make. So every time I am stressing this point, what is that? A list can be an empty list or it can be a non-empty list. So in this case, what happened? In place of L1, we are having a non-empty list. Means we are not taking any elements of this list 1 for performing the concatenation. But in this case, if it is a case, L2 and L3 should be same. Why it should be same? Means, for example, see, this is your L1. Okay. And for example, this is your L2. When you perform the concatenation, what happens? You are going to get ABC as the third list. So ABC third list is exactly matching with the second list what you have taken. That's why if the first parameter or first argument of the concat function is empty list, then the next 2 lists must be same. These 2 must be same. Okay, so this is one kind of observation we need to know. If the first argument of concatenation is a non-empty list, if it is a non-empty list, right, then obviously we know that must have head part, and at the same time it must have the tail part. Okay. So this is the graphical representation how we can show the concatenation of 2 lists. Okay, so in this case, what happened? X and L1 and L2. So whenever you do you perform this operation, the output you are going to get is L3. So from where you got this L3 means from this particular list. Okay. So these are the 2 different operations that we can perform on list, and we will try to see more operations in the coming session. This is the reference from where I have taken the content used in this particular slides. Hope you understood the concept of list and how this list can be represented, and what are the two different operations that we can perform on the list. Okay, we will meet in the next session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.